Welcome to the DIY Honda Garage channel. The DTC code P0135 refers to a malfunction occurring within the A-fuel or air-fuel sensor 1's heater circuit. The A-fuel sensor plays a crucial role in measuring the air-fuel mixture in the combustion process, which is vital for optimal engine performance and emissions control. Located pre-catalytic converter in the exhaust system, this sensor provides feedback to the powertrain control module, PCM, for appropriate fuel adjustments. A malfunctioning heater circuit may prevent the sensor from reaching necessary operating temperatures, leading to inaccurate readings. When the PCM detects this sort of malfunction, it stores the fault code P0135 and illuminates the check engine light to alert the driver. Understanding the role of this system is key to effectively troubleshooting this issue. The AF sensor 1, also known as the oxygen sensor, is directly involved in monitoring the air-fuel ratio of the engine's exhaust gases. It is strategically placed in the exhaust line before the catalytic converter, allowing it to analyze the gases being emitted from the engine. This sensor's primary function is to send real-time data about the air-fuel mix to the PCM, enabling the car to make precise fuel adjustments for efficiency and emissions control. A fault in the heater circuit of this sensor can lead to delayed readiness, causing suboptimal performance and increased emissions. The heater component is vital because it needs to warm up quickly for accurate readings, particularly during cold starts. If the heater circuit fails, the sensor may not operationalize properly, leading to DTC P0135. Several potential causes can trigger the DTC P0135. First and foremost, the AF sensor itself may be defective, including its internal heater circuit, which prevents it from reaching operational temperature. A blown fuse, specifically fuse number A11, located in the underhood fuse relay box, could interrupt the power supply essential for the sensor's heater. Additional wiring issues can also lead to faults. Frayed or shorted wiring could disrupt electrical flow to the sensor. Lastly, while less common, a malfunction within the PCM could also be at fault, potentially misinterpreting or mismanaging signals from the AF sensor. Each of these elements should be checked systematically as part of the troubleshooting process. When the DTC P0135 is present, various symptoms may manifest. The most immediate sign is the illumination of the check engine light, CEL, alerting the driver to a potential issue with the engine's emission system. Alongside this, drivers often notice a decline in fuel economy as the engine does not receive accurate readings to optimize fuel delivery, leading to overconsumption. Elevated emissions levels may also be observed, which can lead to failing emissions tests, especially in regions with strict environmental regulations. Finally, drivers may experience rough engine idling or hesitations during acceleration due to the improper fuel mix. Recognizing these symptoms can help in the timely diagnosis and rectification of the DTC. The first step in troubleshooting DTC P0135 involves verifying the problem by checking the vehicle's status through the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on mode, but do not start it yet. Utilizing the HDS, clear any previously stored DTCs to create a fresh slate for testing. Start the engine and hold the RPM at approximately 3,000 without any load. This operation will allow the engine to reach normal operational temperatures, where the heater function of the A-frame sensor should ideally kick in. After the engine has been running under those conditions, check again for any current or pending DTCs with the HDS. If P0135 is still indicated, this confirms that the issue is present and requires further investigation. In the second step of the troubleshooting procedure for DTC P0135, it is crucial to recheck for any pending or confirmed DTCs using the HDS. About other related fault codes, specifically DTC P1658 or P1659, these pertain to the ETCS control relay functionality. If either of these fault codes appears, it indicates a problem with the engine torque control system, which could indirectly affect the operation of the AF sensor by altering engine behavior during various driving conditions. If these codes are present, follow through with their specific diagnostic steps to resolve the issues. Otherwise, if no new DTCs are recorded, proceed to the next step in the troubleshooting guide. For step 3 in the troubleshooting process of DTC P0135, turn the vehicle to the off or lock mode to safely check the fuses. The focus will be on fuse number A11, which is a 7.5A fuse located in the underhood fuse relay box. After ensuring safety protocols, inspect the fuse to determine its condition. If the fuse is intact, it indicates that the circuit is generally functional, allowing the flow of electricity as intended to the AF sensor. However, if the fuse is blown, it means that there's likely a short circuit affecting the IGPS, or Integrated Gain Position Sensor, which needs immediate attention. Repairing any short in the circuit and replacing the fuse would then be the necessary course of action. Moving on to step 4, you must first disconnect the AF sensor's 4P connector to assess the internal heater resistance. This is crucial, as measuring the resistance allows you to evaluate whether the heater within the AF sensor is functioning correctly. With the vehicle in off or lock mode, utilize a multimeter to measure the resistance between test points 1 and 2 on the sensor. For a properly functioning sensor at room temperature, the resistance should fall within a specific range of 2.2 to 2.7 ohms. If the measurement indicates a resistance outside this range, it signifies that the internal heater component may be defective, leading the technician to conclude that replacement of the AF sensor is necessary to rectify the issue. Step 5 requires checking the internal circuit of the AF sensor for continuity. After ensuring the vehicle is in the off or lock mode and that the sensor's 4P connector is disconnected, you must examine the continuity between defined test points. The test points vary based on the terminals of the AF sensor, and if continuity is confirmed without interruptions, it means the internal circuit is functioning correctly. However, if continuity is absent, it indicates a failure within the sensor's internal wiring, leading to inaccurate readings and necessitating a replacement of the AF sensor. This step is crucial as it leads to determining the next course of action based on the sensor's operational integrity. In step 6, it is imperative to check for a shorted wire in the AF-HT line leading to the AF sensor. Start by jumping the SCS, or the service check switch, line using the HDS and wait for more than 1 minute to ensure accurate readings. After completing this, you will disconnect the PCM's connector C, which contains multiple pins responsible for sending and receiving signals. With the PCM disconnected, you check for continuity between designated test points, one being the PCM connector and the other connected to the body ground. If continuity is confirmed, it suggests that the wire is compromised, and you would proceed to repair any shorts found in the AF-HT wire between the PCM and the AF sensor. This step is crucial for ensuring that electrical signals necessary for sensor operation are not disrupted. Moving forward to step 7, checking for an open wire in the AF-HT line is essential to confirm that the electrical connection to the AF sensor is intact. Adaptive testing should be done while ensuring that the vehicle remains in the off or lock mode and that both the AF sensor and PCM connectors are completely disconnected. Use a multimeter to assess continuity between the appropriate test points. If continuity exists, this indicates that there are no breaks or interruptions in the wire, meaning the AFHT line is functioning correctly. However, if there is no continuity, this indicates an open circuit. The technician should repair the broken line. Ensuring robust wiring is vital for sensor operation and for resolving the DTC. The final step in the troubleshooting process for DTC P0135 involves checking the voltage across the IGPS, LAF Plus line to see if it is transmitting the appropriate power. First, convert the vehicle to the on mode, ensuring that the engine is not running. With the AF sensor's 4P connector and the PCM connector C disconnected, you should measure the voltage across defined test points. A proper reading will show battery voltage, confirming that the IGPS LAF Plus wire remains intact and is functioning as intended. If this voltage is absent, repair work is warranted on the wire running between the AF sensor and the relay circuit board. This step ensures that appropriate energy supply to the AF sensor is active, allowing the heater circuit to operate smoothly. After all necessary repairs for DTC P0135 have been completed, it is essential to conduct a final verification process to ensure that the issue has been resolved. Begin by clearing any stored DTCs through the HDS to create a fresh state for testing. Following this, monitor the vehicle for any immediate reoccurrence of the DTC, as this may suggest that further issues remain. Finally, perform a road test under varying driving conditions to evaluate the A/F sensor's functionality. Ensure that the engine operates smoothly and that no new DTCs appear on the diagnostic tool. This comprehensive verification is critical for restoring full operational functionality to the vehicle's emissions system. To avoid the reoccurrence of DTC P0135 in the future, implementing preventive maintenance strategies is essential. Conduct regular checks on the AF sensor to ensure its operational integrity, ideally during routine service intervals. Monitoring electrical connections for signs of wear, such as corrosion or loose terminals, can prevent future connectivity issues that may lead to DTCs. Additionally, replacing any worn or damaged wiring in the sensor circuit can significantly reduce the chances of short circuits or open wire issues. This proactive approach will help safeguard against malfunctions in the air-fuel mixture regulation system and optimize vehicle performance and safety. In conclusion, the DTC P0135 highlights issues related to the A-factor AF sensor 1 heater circuit, which is vital for maintaining an optimal air-fuel ratio in the combustion process. Effective diagnostics are crucial for accurately identifying the root causes behind the malfunction, whether it's a faulty sensor, blown fuse, or damaged wiring. Regular checks and maintenance of the A-factor sensor and its related components will significantly reduce the likelihood of encountering similar DTCs in the future. It is not only essential for optimal vehicle performance, but also plays a vital role in ensuring compliance with emissions regulations. By following the outlined troubleshooting and preventive measures, technicians can efficiently address and rectify DTC P0135, restoring the vehicle's functionality and reliability. Please like and subscribe to the channel. See you next time.